Imagine if one day you had to live without electricity. Now, imagine a week with 4 out of 7 days of power, and that continues for many years. What would your life be like? That was the scenario for South Vietnam in the late 20th century. In that context, a crazy plan was proposed to build a 500 kV north-south ultra high-voltage transmission line stretching 100 km to bring electricity from the north to the south. At the time, this option was considered far-fetched. Even the superpowers have never had such a precedent. It was a difficult problem with a near-zero probability of being solved. Even foreign experts didn't believe Vietnam could successfully build this power line. So, how did the Department of Energy solve that problem? Before delving into the stories behind the North-South 500 kV high-voltage power line project, we need to return to the historical, economic, and social context of Vietnam during that period. In the spring of 1975, the United States officially withdrew from Vietnam, ending the war. However, the U.S. subsequently imposed a trade embargo on all of Vietnam. At that time, Vietnam was simultaneously facing harassment from Chinese troops on its northern border, Pol Pot's forces on its southwestern border, and remnants of domestic opposition. One might have thought that this would become an obstacle, hindering Vietnam's development, but the result was the opposite. In the late 1980s and early 1990s, Vietnam entered a new era. Industrialization and modernization are being carried out nationwide. The economy is showing signs of remarkable growth, especially in heavy industry. The number of industrial enterprises has increased significantly. Several large industrial zones have been established. Just a few years after reunification, South Vietnam was planned to become the National Industrial Center. But it was precisely that rapid pace of development that nearly plunged Vietnam into a perilous situation. Despite industrial development, the South suffered from a severe electricity shortage. Without electricity, it's impossible to maintain and develop production and business activities, leading to a series of negative consequences for the Vietnamese economy. To put it simply, it would halt the development of a country that has just ended a war. Meanwhile, the North has a surplus of electricity, but the North could not immediately supply electricity to the South. Why is that? At that time, Vietnam's power system was divided into 3 separate regions: the North, the Central, and the South. At that time, the northern region had several large thermal power plants such as Hoa Lai, Ong Bai, etc. In particular, the Ho Bin hydroelectric power plant had the largest designed capacity in Southeast Asia at 1920 MW. However, the demand for electricity for industry in the north is not high, causing supply to exceed demand, leading to a surplus of electricity. The central region is primarily supplied with electricity from several small, local diesel generators and the 220 kV transmission line from the Hoa Bin hydroelectric plant. However, the electricity supply only meets more than 40% of the demand in central Vietnam, because the distance between power supply points and loads is still too long, limiting transmission capacity and resulting in unreliable power quality at the end of the line. Just imagine if the power grid in the north supplying the central region with a length of 203 km, already makes transmission so difficult. Imagine how much more challenging it would be to transmit electricity to the south, with a distance nearly 10 times greater. In the south, which was then planned to become the National Industrial Center, there was always a severe electricity shortage. The entire southern region only had the Trian hydroelectric plant with a capacity of 440 MW, the Denim hydroelectric plant with a capacity of 100 MW, and many old diesel-powered power plants like Tra Ngoc and Thu Duc, abandoned by the South Vietnamese government. This system was previously provided as aid by the United States. However, after 1975, the diesel power generation system was almost completely shut down due to the U.S. embargo. Prior to 1991, the Soviet Union also provided oil to Vietnam to operate this system, but the amount was insignificant. At that time, Saigon had to experience rotating power outages for 3-4 days a week, or even 5 consecutive days each week. The economic damage is enormous. According to calculations, a 24-hour power outage would affect the city. Ho Chi Minh City suffered losses amounting to 45 billion VND. Professor Tai Phung Nhi, former Minister of Energy, stated, at that time, foreigners said, "If you keep inviting us to do business here, we won't come." The electricity shortage was the biggest obstacle preventing foreign businesses from investing in Vietnam at that time. To save the South, the then Prime Minister of Vietnam, Vo Van Kiet, issued a directive. Electricity must be brought to the South as quickly as possible, at all costs. Faced with this situation, 2 options were proposed. The first was to sell the surplus electricity from the north to China to fund the construction of a new thermal power plant in the south, similar in scale to the Hoa Binh hydroelectric plant. The second option was to build a high-voltage transmission line from the Ho Binh hydroelectric plant to the south. At that time, China, with its massive population, was also experiencing a severe electricity shortage. So selling the surplus electricity could generate hundreds of billions of dong. Combined with existing experience, building a new thermal power plant was within the capabilities of domestic engineers. Therefore, the option of selling surplus electricity to fund the construction of a new thermal power plant in the South was supported by most members of the government. However, the problem was that building a thermal power plant would take at least 6 years. The people would suffer for that much longer. Southern industries would face electricity shortages for nearly another decade, meaning a further 10 years of hindering the country's development. Therefore, this policy was not implemented. The plan was rejected. The Ministry of Energy proposed an even more outrageous solution, building a 500 kV super high voltage transmission line connecting the north and south. However, this plan faced much opposition. It was considered unrealistic and unfeasible. Some government members argued that this is an adventurous, risky policy, a waste of national resources, and only for prestige. But why? With the level of technology at the time, building a super high voltage transmission line spanning thousands of kilometers was difficult even for superpowers, let alone Vietnam, a country that had just emerged from war. However, Prime Minister Vo Van Kiet strongly supported this project. He gave the Ministry of Energy an ultimatum to complete the line within 2 years. But why 2 years? Vu Ngoc Hai, former Minister of Energy, why did Mr. Kiet say 2 years? Because once he asked me, The South now also, the power shortage is starting to become apparent. So when will the shortage be most severe? I told Kiet it will be in 2 years. The reason the 500 kV power line project was chosen was precisely because of the time factor. Therefore, this project will only be effective if the construction is completed within 2 years. Every day of delay means a day of wasted national budget. This project has shaken not only public opinion, but also the scientific community, both domestically and internationally. Professor Academician, Doctor of Science Tran Din Long. There is no consensus among the highest-ranking leaders, ministries, sectors, and especially experts. They believe this project is too large, 1487 km, wavelength. It will cause instability and safety hazards. Therefore, it shouldn't be taken as a risk. Building it will fail, while the government and relevant agencies were struggling to resolve the complex issues. A Vietnamese-American professor teaching at the University of Grenoble in France sent a letter to the Central Committee outlining 3 points of opposition to the proposal. First, the one before wavelength problem. Each electromagnetic wavelength has a length of 6,000 km, while the planned length of the transmission line is 1,500 km, which is exactly 1/34 of a wavelength. This is extremely dangerous. According to this professor's explanation, electromagnetic waves have a sinusoidal shape, and 100 pi4 of a wavelength is exactly at the peak of the sinusoid. If the electromagnetic field in Hanoi reaches its minimum level, it will reach its maximum level when transmitted to Saigon. Conversely, if the voltage is at its maximum in Hanoi, it could drop to 0 by the time it reaches Saigon. In that case, it would no longer be 500 kV but could surge to 700 kV or 1,000 kV, causing all equipment to burn out. In addition, the power supply is weak, only supporting one circuit, so its reliability is not high. Secondly, no country in the world has been able to complete a power transmission line of similar length in 2 years. At that time, the longest power transmission line in the world was the European grid, spanning nearly 800 km and taking almost 8 years to build. And third, building a 500 kV power line under difficult financial conditions, requiring borrowing and interest payments, is not economically viable. It could be said that the North-South 500 kV high voltage power line project was built with the most zeros, no experience, no funding, and no support. So how did the Department of Energy address each of those bottlenecks? Faced with public outcry and conflicting opinions within the government, Prime Minister Vo Van Kiet firmly stated, "Those who support it should join the ranks. Those who do not support it should stand aside. Just do it. If it fails, I won't wait for dismissal. I will resign voluntarily." Prime Minister Vo Van Kiet. There's no more debate, no more talk about whether to do it or not. The only discussion is how to get the power lines to the south as quickly and urgently as possible within 2 years. On April 5, 1992, Prime Minister Vo Van Kiet issued the order to commence construction of the project. Firstly, to address the Wonka 4 wavelength problem, the Ministry of Energy invited experts from PPI Consulting Company, Australia, to provide advice and jointly find a solution. Professor Tran Din Long, the project's chief technical consultant, proposed installing 4 substations along the power line. The purpose of a transformer substation is to bring the current down to areas where it is rising. Conversely, in areas where the power supply is weak, This compensation station will supplement it to ensure that the voltage of the electricity remains stable. According to Professor Tran Dien Long's calculations, 4 substations will be installed in Ha Tin, Da Nang, Pleiku Gia, and Phu Lam, Ho Chi Minh City. Thus, the quarter wavelength problem has been solved. But there's another difficult problem: the time it will take to complete the project. How will Vietnamese experts complete such a massive project in 2 years? Building a 500 kV power line is difficult, but building a 1500 kV long 500 kV power line in 2 years is even more challenging. Therefore, the plan for constructing the power line had to be changed. That means not constructing each section sequentially, but rather organizing the commencement of construction for the entire route. Divide the route into 4 segments. Each section was assigned to a different construction company for electrical installation. With this phased construction approach along the entire route, completing the project within 2 years is highly feasible. The Department of Energy had to mobilize 43,000 people from the electricity, construction, defense, and transportation sectors, as well as countless local residents, to carry out the project. Section 1, from Hoa Binh to Ninh Giang, is being undertaken by Power Construction Company No. 1. Section 2, from Ha Tin to Kon Tum, is being undertaken by Power Construction Company No. 3. Section 3, from Kon Tum to Dak Lak, is being undertaken by Power Construction Company No. 4. And Section 4, from Dak Lak to Phu Lam Sai Ho Chi Minh City, is being undertaken by Power Construction Company No. 2. Of these, Section 2, from Ha Ting to Kon Tum, spanning 6-4, is the most difficult and complex, with over 400 km consisting of hills, mountains, and dense forests, along with numerous sections requiring crossing large rivers. The rugged mountainous terrain makes transporting machinery and construction materials to specific locations more difficult than ever. There were many locations inaccessible to machinery, so workers had to use wheelbarrows and carts for transportation, and especially had to mobilize local people to carry bags of cement and sand up the steep mountaintops to lay the foundations. For example, when casting foundations on the top of Hai Van Pass, Dai Loc Hills, Giang Wharf, Lo So Pass, Mr. Tran Viet Ung Gay, former Deputy General Commander of the North South 500 kV power line construction project. Foreign countries use machinery for construction and erect poles with helicopters. In our country, we build by hand with our own 2 hands. We struggled with millions of tons of concrete and millions of cubic meters of rock and earth, day and night without rest, continuously for 2 years to complete this project. But that impossible feat became a reality, which is admirable. After more than 2 years of construction, PM on May 27, 1994, the North-South Power Line officially began operating along its entire length. The 500 kV North-South High Voltage Power Line has been completed with 3437 steel poles passing through 17 provinces and cities, crossing rivers 7 times and national highways 17 times. 1487 kilometers of power lines and lightning rods, 22 fiber optic stations, 19 line operation points, 280,000 cubic meters of concrete and 23,000 tons of reinforcing steel, along with 60,000 tons of power poles, 23,000 tons of conductors, 930 tons of lightning protection wires, and 6,300 tons of insulators. The completion of the 500 kV North-South Ultra High Voltage Power Line has unified the power system of the 3 regions of Vietnam. The South's electricity shortage has been completely relieved, ending the North's electricity surplus and ensuring sufficient power for the central region. As a result, the nationwide growth in commercial electricity consumption increased from 5.6% in the 1999-92 period to 18.2% in the 1993-97 period, peaking at 20% in 1995, with the central and southern regions reaching 25%. These contributions have played a significant role in the overall development of the Vietnamese economy, with GDP growth increasing from 5.1% in 1990 to 9.5% in 1995. The central and southern regions accounted for 25%. These contributions have played a significant role in the overall development of the Vietnamese economy, with GDP growth increasing from 5% in 1990 to 9.5% in 1995, and average industrial output growth reaching 12% to 14% during the period from 1990 to 1995. Among hundreds of solutions to the electricity shortage in the South, Vietnam decided to choose the most difficult, most costly, but also the most sustainable path for Vietnam's future development.